Good day, folks. Welcome to my YouTube channel. This is another question of work energy and power that involves power calculation. Let's cut the chase, guys. Don't forget to subscribe on my channel and like and share with all your friends. Watch my video till the end. It says in South Africa, the transportation of goods by trucks adds to traffic problems on our roads. A 10,000 kg truck travel up a straight inclined road of length of 23 meters at constant speed of 20 kilometers. Now it says the total work done by an engine of the truck to get there is this: 7 times 10 to the power 7, 7 times 10 to the power 5. The work done to overcome friction is that. Okay, very important to underline what we have. We have a speed there, it's a constant speed, so we change the speed by dividing by 3.6. right? So dividing by 3.6 there, our speed there, it's going to be 5.56 meter per second. And then this is the work done by the force of an engine of the truck, and the work done to overcome friction. This is the work done by what? By friction. And this is the displacement of the truck, right? This is the initial velocity of the truck, and this is the final velocity of the truck, and this is the displacement. And the height we are not given there, so the truck moves up in an incline there, and we are not given the angle of inclination there, right? Calculate the question, calculated the height reached by the truck at the top. So we wanted this height there, so this is the height initial and this is the height final. We wanted the height final. The height initial is 0 there. Remember, when an object moves at constant velocity, its acceleration is 0 and the f net is 0. And now it moves at constant velocity, that means the acceleration is 0, the f net is 0, so the work net is equal to 0, and the change in kinetic energy is 0. It's very important. Now in 6.1.1, to calculate, we will use the work done by non-conservative force is equal to change in EK plus change in EP, right? The work done by non-conservative force there, the non-conservative force there, it's the friction plus the work done by the force of an engine. We're given both is equal to change in kinetic energy plus change in gravitational potential energy. Now what is the work done by friction there? And the friction opposes the motion there, so it's going to be negative 8.5 times 10 to the power 4 plus the work done by force of an engine is going up the slope. It's 7 times 10 to the power 5, right? And then the kinetic energy there, since it moves at constant velocity, so there's no change in velocity, that means no change in kinetic energy. And then the gravitational potential energy, we know it's mgh final minus mgh initial. So the mass of the truck is 10,000, which is the mass, 10,000 times 9.8, and then we wanted the height final, which is the height final. It's going to, we wanted the height final and the height initial, it start from the bottom, which is at 0. And then when you do the math there, the height, guys, there, it's going to be 6.28 meters per second, right? The next question here, it says the instantaneous power delivered by the truck. We wanted the power delivered by the truck. So it's very important here to know that the formula for power is equal to W over change in T. So what will be the work here? It's the work by, it will be the work by the force of an engine of the truck, right? So we need to get the we need to get what from here we have we need to get the work done by the force of an engine, but we do not have time as well. So we do have these two, but we do not no. So we have two unknowns here. We have this and this, right? We do have the force of an engine, so that means we're going to use this formula. We're going to use this formula that says P is equal to force average times by the constant speed. So this will be the force of an engine and the constant velocity we do have. How are we going to get the force of an engine? We'll use the work done. Okay, let's do it. So we'll say the work done by the force of an engine is equal to force of an engine change in x cos theta. So we do have the work done by the force of an engine, which is 7 times 10 to the power 5, and we're looking for the force of an engine so that we can substitute it here. The displacement, what is the displacement, is 23, and then cos 0. The force is going in the same direction with the displacement there. So when we punch that in the calculator, so you get the force of an engine with an answer that is 3,04 times 10 to the power of 4 newtons, right? What are we going to do with that? We go to the formula of power. Power average is equal to force times velocity, which is the force now. It's 3,04 times 10 to the power 4. And then the velocity is the constant velocity, right? Which is the 20 divided by 3.6, right? Our answer there, it will be 1.6. By the way, it's 5.56. It's 1.6 times 10 to the power 5 watts. That's the power there. And then let's move to the next question. The next question there, it says an arrestor bed are constructed as a safety measure to allow trucks to come to rest when the brake fails while going down the hill. Write down two design features such as arrestor bed. The design feature there, guys, it's going to be, is it 6.3 or 6.2? Yeah, 6.2. The two design, guys, there, I'm gonna say it in words, I'm not gonna write it. The surface must provide sufficient friction like sand. So the surface of the arrestor bed must provide a sufficient friction like sand, and it must be long enough to stop the vehicle. So if you look in the freeways, in the downhills like mountain here in Cape Town, in the downhills we have arrestor beds where the truck, if the brake fails, it will take an off ramp and go to the arrestor bed. The arrestor bed, it's a long road with sand, the sand like a desert sand, where the truck will experience a friction and eventually stop. So that sand creates friction between the truck wheels and the surface, and then it must be long enough so that the truck can eventually stop. Those are the two: sufficient friction by the sand, and it must be long enough. Thank you guys so much. I hope you understood.